Okay, we are in this video we're going to look at subdividing structural isomers, and remember that there are three different sorts of structural, there's three different categories. You can have functional group, you can have chain, and you can have positional isomers. Okay, and really these three terms are only meaningful when you are comparing two molecules with each other, and you can either say they're functional group isomers of each other, they're chain isomers of each other, they're positional isomers. You can't just say this molecule is a positional isomer. That doesn't make any sense. You've always got to be comparing it to something else. Okay, so last time we looked at some alkenes, but this time we're going to look at all the molecules have got this formula, C4H10O, and if you look at the carbon hydrogen ratio there, that is CnH2n plus 2. So there's no double bond in that molecule at all, and they can't be cyclic either because it's not 2n, it's 2n plus 2, and because there's no oxygen in it, a lot of those are going to actually be possible molecules are going to be alcohols. So you can see here we've got butanol. Here we've got butan-2-ol. Here we have got 2-methyl-propan-1-ol. Here we've got 2-methyl-propan-2-ol. And then this one here, where the oxygen is forming like a bridge between the two alkyl groups, this functional group, which is we don't really come across, is an ether. We don't really do much about the chemistry of ether groups at all. Don't confuse it with an ester, it's not quite the same, it's an ether. Right, and we'll just have a look at that. Right, so let us compare. Let's use our little flow chart up here to compare these, what these are. Okay, so let's look at, let's just call them 1, 2, 3, 4, and 5. Let's look at numbers 1 and 2. Right. Do they have the same functional group? Yes, they do. They both have got an alcohol functional group. So move on to the next question here. Do they have the same carbon backbone? They do. They both got 4 in a row with no branches. So they must be positional. That's easy enough. Okay. Let's now look at, let's say 1 and 3. What kind of isomers with each of this? Right. Do they have the same functional group? 1 and 3, yes, they're both alcohols. So move on to the next question. Do they have the same carbon backbone, 1 and 3? Well, they don't. Look, number 1 has 4 in a row, number has 3 in a row with a branch on it. So that means these are chain isomers of each other. Let's now have a quick look at numbers 1 and 5. Let's do that. Okay. Do they have the, so the questions again, do they have the same functional group? No, they don't. Number 1 is an alcohol, whereas number 5 is this thing, the ether. So they are functional group isomers. Right, let's choose 3 and 4. 3 and 4. So, right, same functional group. Yes, they're both alcohols. So move on to the next question. Do they have the same carbon backbone? Yes, they do. They have 3 in a row with a branch coming off the middle one. So let's move down to yes. They must be positional isomers of each other. So that's what the answer is there, positional isomers. Just do one more comparison that we haven't done. Let's do 2 and 3. Okay. So 2 and 3 do the same functional group. Yes, they do. They're both alcohols. Do they have the same carbon backbone? No, they don't. 2's got 4 in a row, and 3 has got 3 with a branch coming off it. So they must be chain isomers of each other. So hopefully you should know how to use that little flowchart in your head to determine what kind of subdivision of structural isomers two molecules are of each other. Are they functional group, are they chain, or are they positional? Okay, nice short one there.